Okay, we're up on the beach now. These are my two goofy kids a couple years ago in the sand. Coastal areas are the land edge that borders the sea. So we're talking about the area sometimes covered by the water, depending on the tides, and sometimes not. The shore is the outer limit of wave action on the bottom to the limit of the wave's direct influence on land. So from wave base, kind of where the wave action is, up to where like the highest high tide. And the beach is the accumulation of sand or gravel that occupies the shore. We're going to classify beaches in different ways. The first way is whether or not the beach is at a plate boundary. So at an active margin, there is a plate boundary. The shoreline coincides with either a transform or a convergent plate boundary at a subduction zone. At these kind of plate boundaries, they're going to look very different than the North Carolina plate or North Carolina passive margin. Here's the North Carolina passive margin. Here's the coast of California that's an active margin. There's cliffs above the waterline. The continental shelf, instead of being a real broad shelf, now is going to be a narrow continental shelf. Any of the sediment shedded off the land is going to go down into the trench. There is going to be a steep drop off offshore. So instead of the broad shelf and then the rise and the slope, there's going to just be a drop off. There are also earthquakes, which can cause landslides. There's cliff erosion. And there may be volcanoes, and this area may also be subjected to tsunamis. That's different than a passive margin where there's no plate boundary. The continental shelf is going to be really broad, big, wide, miles wide continental shelf. The beach is often broad. There's not going to be very much associated cliffs. The shore is sandy. There are oftentimes barrier islands. This is North Carolina, the Pamlico and the Albemarle-Pamlico Sound. And this is the barrier islands of the Outer Banks. And those go all the way down to around Myrtle Beach in South Carolina. These areas are, because they're low-lying, the relief is really low. They're more sensitive to sea level rise. As sea level rises, more of the land can be inundated by seawater. There are estuaries. Estuaries are those, like here in the Outer Banks, it's the back beach area here between the mainland and the islands. Those estuaries have what we call brackish water. So they have an influence of fresh water, but also through the tidal inlets, the tide does go in and out of those estuaries, and they're really easy to pollute. And then for North America, our passive margin here on the East Coast, we have hurricanes. Okay, so another way, so that's one way to look at coastlines. Another way is how they formed. And I have a couple slides on each of these, but we think of them as a primary coast and a secondary coast. A primary coast is going to have a lot of influence from what's happening on the land. A secondary coast, you can think of it having a lot of influence by what's happening in the water. Okay, so for a primary coast, they owe their character and appearance to processes that occur at the land-air boundary. They have not really been significantly changed by marine processes. These would be places where rivers come in and their delta is going to form when they drop their sediment. Drowned river estuaries, that'd be like what we just looked at with the Pamlico and the Albemarle Sound. Those are two rivers that seawater goes up into during high tide, and it's an estuary. Fjords are similar. They're rivers, river valleys, but they're U-shaped because a glacier has carved them and water goes up in and floods them, and they're fjords. Volcanoes can be at the beaches, and then tectonics, remember, an active margin is a continental margin that has a plate boundary, and tectonics, they're like the movement of the rocks. We can have earthquakes, and so a lot of uplifting and maybe even down dropping because of earthquake activity and that plate motion. Last one there is uplifted, formerly glaciated coast. When glaciers sit on the crust, they're going to push it down, and then when the glaciers come off, that land pops up. So push it down, and it's rebounding after the glaciers melt away. So a secondary coast is going to be really more about the marine influence. So these would be places where there's a beach. There are places where there are barrier islands, coral reef offshore, mangrove swamps, and saltwater marshes. So these are all characterized by influences of what's going on with the water. All right. So processes that create these primary coasts: erosion of the land by running surface water, wind, land, ice, followed by sinking of the land or rise in sea level. So remember, rising and sinking of the land with the isostasy and the rebound from the weight of the glaciers. There's that sedimentation and erosion of the continents and the sediment coming in and forming a delta. Examples like that. So deposition of sediments carried by rivers, glaciers, or wind, and then perhaps maybe it's an active boundary and there's volcanic activity, and then that movement of the land by tectonic activity. All right, last one for primary coast. I'm going to turn my face off for now, get it out of the way. So we can classify these primary coasts even further by saying that the processes are erosional, depositional, volcanic, or tectonic. And here, this first example is the fjord, a U-shaped valley that's been flooded. And so that's an erosional remnant of glaciation, and now it's at the coastline. And here we have a drowned river valley. Dunes are also an example of sediment coming from the land. Okay, sorry about that. Glacial moraines. These are places where glaciers have deposited a ridge of sediment, and then that sediment can be reworked by the sea. And then a delta, deltaic, is where rivers come into the water and drop their sediment. Volcanic activity, there can be lava flows. I don't know why this keeps beeping. Lava flows that reach the sea. Craters, there can be craters that are flooded by seawater. So a volcanic remnant that is at the ocean can get eroded, and then seawater can flood into it. There can be faults at the coastline. So this is a fault here, Baja California. There's a divergent plate boundary kind of splitting off Baja California south of California and Mexico. So those are examples of influences by what's happening on the continents, and that is reflected in the beaches. Okay. Secondary coastlines. So this picture here is a mangrove tree, and the mangroves have those real interesting root systems that come off of them, and those are going to trap sediment and create like a mangrove forest at the beach. So with these, we're thinking about what the ocean is doing instead of the land. So it's erosion due to waves, currents, or dissolving action of seawater, deposition of sediments by the waves, the tides, the currents. So speaking of it in terms of what the water's doing, and alteration by marine plants or animals. So this mangrove forest is an alteration by a marine plant. It traps sediment and create a dense forest that is a real interesting habitat for fish and birds. All right, more secondary coast. So erosion examples: regular cliff coast. So that would be like in A here, there is a cliff. In B, here is a irregular cliff coast where the wave action has left these sea stacks, they're called, and those are actively eroding over time, but for now they're left as sea stacks. Depositional, these other images here as well. So the way this would progress, if you start with A, perhaps you can start digging in on one point of it and it would progress to C, and then maybe a hole goes all the way through, you get to D, and then that arch collapses and you're left with B. That's the sea stack that's left over from that. Okay, depositional examples like barrier islands, shallow coasts with abundant sediment, and sand spits. This is a sand spit here, so this is a barrier island coming down, and then currents have flowing to the, let's just say to the south in this image, to the bottom, have created this spit. Beach plains, flat areas of elevated coastal seashore, mud flats and salt marshes. That would be like this image down here, H. Built by marine organisms, so coral reefs in F. The letters are really small. In F, this is a coral reef coming off of this island, and it's built up over time. The mangrove coast here in the middle, this is a mangrove tunnel. Oftentimes people will cut little trails. You can kayak through the mangrove forest. And then here's a marshy grass coastline, so a marsh at the beach. Okay, those are all secondary coastlines. All right, parts of the shore face here. The back shore, the foreshore, and the offshore. The back shore is the berm or berm and berm crest. So the berm are these kind of these humps here. There's a berm scarp, a summer berm, and a winter berm. They're just the lumps here on the beach that are formed because of wave action, and storms. The foreshore is the high or low water shorelines. So that is going to be sometimes underwater, right? So the area between high and low tide. They can have wave cut scarp, so waves can come into those berms and cut it off, and you can have like a little step there. Low tide terraces, so at low tide there can be a obvious step down in a low level below the berms. There's the beach face. And then the offshore, there are troughs and bars. Troughs are going to be just low points, and bars would be like a sandbar. Parts of a beach. So here is a summer berm. That's this hump here. There's sedimentation, and this this sand is deposited on the beach during kind of the calm summer months. In the winter, that would get eroded off and maybe become a sandbar out in the water. Here's a beach scarp where there's a step down off of that terrace. All right, these are ridges and runnels. My kids always love the pools at low tide. That's what this runnel is here. And then the ridge is like a sandbar off the beach. Okay. All right, it's a dynamic environment with natural processes building the beach and moving sand around. Turn me back on here. In the waves, there's gentle waves, and sand is moving shoreward. That's why we have that summer berm. In the winter, large storms are going to eat at the beach and create these sandbars just offshore. Also, along with that, there's onshore and longshore transport. This is the movement of sand because of waves. And we'll look at images of what that looks like. But sand moves onto the beach and off the beach, and also up and down the beach. And the waves are swashing back and forth in that swash zone. There can be springtime river flooding that brings sedimentation, brings sand down to the beach, and the deposition of it, sedimentation. There can be really big storms like hurricanes, and also landslides. I have a dog trying to get me to pet it. Okay. Really? Hey. Okay. Pause for a minute here. Stop.